Hello and welcome. My talk will be in English. My Hebrew consists of 3 words, I think. Which is not sufficient for a talk like this. Anyway, topic is challenges of Git in the enterprise. How dare I speak out against Git coming from Perforce? Silly question first. Who is not using Git? Come on, show yourself. Don't be ashamed. Of those people who don't use Git, who is using Perforce? Okay, very good. Thank you. All right, so who of you is working in an enterprise company? All right. Have you had any problems with Git? No? All right. Then you're wrong talk. Challenges? What challenges? Let's see if any of these problems are familiar to us. So let's start with the first one, obviously. Are you using Git? If you're using Git, okay, that might be a talk for you. If you don't use Git, you're on the wrong talk. Unless, of course, you plan to use Git in the future and want me to persuade you not to do so. I'm not going to do that, by the way. All right. Are your repositories large as 1 gigabyte? Now, who in his sane mind would do that? Put a repository, Git repository up for 1 gigabyte. We'll talk about the history of Git in a moment and why that is a bad idea. But if you have larger repositories than this, you might have challenges. I have seen people have 50 gigabyte repositories. If you call them mad, you're on the right talk. If you say that's normal, you're probably also on the right talk. Do you have repositories that depend on each other? Obviously, they depend on each other some way, but what I'm talking about here is an enlightened developer using Git looks for microservices or, let's say, building independent jar files that are completely, utterly independent of each other. They will never overlap. If I make a change in one, it doesn't affect anyone else on the other side. They might have to upgrade to a newer version to get a newer version of the API or something like that, but otherwise they're completely independent. If they're dependent of each other, that means that I have to download more than one repository at the same time to be able to build at all. Who in their sane mind would do that? Well, those people who have the problem starting out with encountering the issue with 1 gigabyte is roughly the main maximum size that the repository should have. Everything beyond that will get slow. Unbearably slow, though, if you keep on going at that. So one of the possible tactics might be then to split this problem up into smaller repositories, working them independently. But of course, if you build them, you have to bring them all together again. Does anyone know a project that has to do that? No? Yes? A few of them? You ever experienced that yourself, that you have to do this? You have to download more than one repository, you have them in sync at the same time? You can use subtrees for that as well. Good luck with that. Submodules, you mean? Anyone use submodules successfully in the enterprise? I have not met a single person yet. I've given talks like that for a while now. It's a nice trick. It doesn't work in the reality. Who's got a smartphone? No, wrong question. Who doesn't have a smartphone? That's what I thought. Oh yeah, one person. iOS versus Android. iOS? Android? Okay. You all encounter the problem of having multiple Git repositories depend on each other. You just don't know it yet. Get to that in a second. What else we got? Do you store large binary files inside the Git repository? That's an idea of the bad idea bear. Not a good idea. Now, you might be going back and saying, yes, I use Git LFS. It's fantastic. Speak to the person who has to develop these files, or artist or something like that, has to deal with Git and produce these binary files you put in there. You might want to cover your ears because he will use words or she will use words you will not ever want to hear again. Not a good idea. Finally, do your builds take a long time? Of course, builds always take too long. There's no question about that. But do your builds take a long time because it takes ages to download the stuff from that? Okay, let me rephrase that. If you have lots of build servers hammering against the same poor little server in there that's supposed to serve up your Git repositories, and that server now suddenly goes down. You can't even log in anymore because it runs out of memory, runs out of CPU power because the load going on that. You suddenly discover that Git is fantastic in storing and packing the stuff together. It's very good in cloning small repositories around. Unless 1,000 build services try to do that at the same time. And then you can overload the poor system. Because there's a space-time trade-off. The easier you pack it, the longer it takes to unpack it and pull it across the wire. Okay. So, if any of this sounds familiar, or you're interested about it, this is a talk for you. If you're telling me this is all rubbish, then you're in the wrong talk. All right, a little bit of Git history. Just for those of you who either were born in the Git world and don't know anything else, you might think that there's always been a version control called Git out there, or not interested in history, or just curious about this. So it was around 2005 when Git was developed by Linus Torvald, famously in a long weekend. Why? Well, Linus Torvald, of course, is famous for building the Linux kernel, and for building the Linux kernel and working together with his team around the world, they used a tool called BitKeeper. BitKeeper was similar in concept as Git, distributed, but it was a proprietary piece of software that the BitKeeper team gave to the Linux kernel developers for free. Until one of these guys, sick with the fact that they couldn't work on the client properly, reverse engineered the protocol and built their own clients around that. That got the guys from BitKeeper in a huff. They revoked the license of BitKeeper, and there was a long discussion internally. Linus Torvald was so dependent on BitKeeper, he decided, well, he actually planned to not to stick with the BitKeeper and pay the license fee for it somehow. And other people devoted face and said, you are the champion of free software. This is not working. We need to have open source tools instead. So he sat down famously in a long weekend and wrote a tool. And it was not a version management tool. It was just something to store stuff together with that. That became Git. He gave that about 3 months to Junio Hamano, who is still looking after that, according to Wikipedia at least, who is now maintaining Git itself. It was built right from the idea, similar to BitKeeper and Monotone, as a distributed system without a central server. Nowadays, of course, this is 2005. I encountered Git the first time in 2007, when one of our customers said, well, you guys at Perforce don't do anything interesting anymore. It's too stable. We want something crazy, and picked up on Git. And now, of course, it's, as you just shown yourself, it's the most popular version control system out there. And many people I encounter from university will tell me, for them, version control and Git is the same thing. They don't know that there's anything else out there. I find that a good thing. 10 years ago, when I spoke to the same people at university, and they looked at me, version control, what is that? Now at least they all know it, which is already a progress. The popularity, you can see that there. Git is the blue graph going up. Subversion is disappearing. Thank God for that. Mercurial, unfortunately, is also disappearing. It's a shame. Mercurial, in many respects, I prefer as a system. I'm a Python fan. That's also, and yes, the low line below that is Perforce. Now, these statistics here comes from questions asked on Stack Overflow of please help me with this tool. So I could reinterpret it as well. Git is very complicated, and you have to ask lots of questions. Help me with that merge, and how does the rebase work again? And then Perforce, you can just look up documentation. That would be a mean thing to say, so I'm not going to say that. Right, how does Git actually work? Ever lifted up the cover and looked inside, what actually goes on inside? Who knows more than 5 commands in Git? That's not as many people as I expected to, all right? Good. So a little bit of what goes on internally. In effect, if you open it up and look inside Git, it is nothing else but a hash number against some content, file content. That's all it is. Everything else is built on top of that. So you go on with a hash number, a calculated 40 character char, and then find content, find the file from that. Okay? My files in here are called the blobs. That's actually file content and stuff in there. They're referenced by trees. Trees are directories. The trees themselves are referenced by commits. That's my commit that I write in there. And commits point to other commits, parent commits as well. So I started with one commit, in this case the commit on the right-hand side. That's my original commit in there. That referenced one tree with 2 files in it. And when I make another commit that references the same commit beforehand, all the files that I haven't changed, and adds another tree to that for the file that I have changed. Not that complicated. It's a tree, a Merkle, the variety of a Merkle tree that sets up the stuff with the head on it. All wonderful tree built up with pointers to each other in a file system. Very simple. There are a few consequences of that. One of them is that a Git repository is nothing else but a glorified version of directories, as Linus Torvalds says himself. They're all dependent on each other. You can't just pull bits and pieces out. The consistency is broken. Every single layer that you build is dependent on the consistency of the layers beforehand and protect each other through shars. Which means you have to take always the full repository. Can't do anything else with this. Now, how are you supposed to work with that? You clone them. You take the whole repository completely over. Via clone command, typically have the whole repository history there. That's what the idea of distribute is. I always have a full copy. I can work with that. And then I communicate via shars of which, oh my God, commits, which version I modified and then merged together. And then you can push changes via push command and fetch changes from the server, new changes in that. The original design was like that. It was just independent servers, and then you would throw each other changes, mostly via an email via patches. Then it would just have the content in there, and you send it to Linus Torvalds, and he would then accept it or not accept it in its kernel. That doesn't work in the enterprise. Obviously not. So how does Git actually use? How do you use Git? Well, you would have something like this. You have some kind of Git management tool. Who is not using any kind of Git management tool and really just use a bare-bone Git repository somewhere? One person. Hey! Well done. Okay? It's not that hard to set up, but of course you have no protection and no review and anything else around it and no backup. So mostly use some kind of management tool. One of them might be Gerrit from Google. Gerrit famously is a rewrite of the original Mondian, which was written in Python. Actually 4 Perforce, Google used Perforce at that time. But these days, of course, there's GitHub and so on. GitHub, arguably, is the reason why we're talking about this in the first place. If GitHub hadn't been there to build out the environment on Git, there would be no Git. We'd be talking about Mercurial or some other tool, but it wouldn't be Git. It was GitHub and the decision to use Git as their version management tool and give it a common place where everyone can go to that gave Git its prominence these days. And of course, nowadays you find all open source software there. And the other tools are GitLab and Atlassian Bitbucket, formerly Stash, and there are many, many other tools around there as well. They all solve several problems. One of them is central storage. Important for an enterprise. I want to know where my code is. I don't care that you have it on your laptop. I want to make sure that you have the right version available somewhere I can go to and verify it if necessary. And that only the right people can access the software, and only the right people can make modifications. And I have some kind of workflow around that as well. Any kind of version management tool, Perforce included, will suffer from the fact that if 1,000 people try to modify the same code line without any kind of workflow around it, there will be chaos very quickly, and very soon you're going to throw the thing against the bin. You need to have some kind of way of working this, and one of these particular tools around that has been established in the Git world is the pull request workflow. There are other workflows out as well, Gerrit and so on, that work around this. And with that comes the whole thing of code review, which is one of the interesting parts of that, actually making sure that more than one person looks over the code before it gets checked in. And this is the Jenkins conference after all, CI integration. Somehow verifying that the Starfish stuff you check in there is actually correct. Builds, passes tests, and so on. And then there's automatic process, so you don't have to trust someone. Yes, I have tested this. No, show me, prove me that when you check it in, it is correct. Good. All right, so what are the enterprise challenges that I'm talking about? Well, this is correct. If you said your project consists of small, little Git repositories, independent, because each of them represents one microservice, one jar file, one other package that can be developed independently by a small group of people, and they work together by just using the artifacts, you don't have a problem typically. But what happens if you have hybrid content? So if you're a chip designer, if you're a game developer, something like that, then there is more than one type of files around. Git is designed and optimized for text files. They're easily to merge. But binary content, digital assets are not mergeable. So then you suddenly have a problem. You need to have locking in place maybe, you might have other tools in place, you have other workflows in place to be able to do that. If you mix both together, you have an issue. Now, you can put them in different silos, we'll talk about in a second. Remote access. Git is designed to be working remotely, distributed. So there's no issue with that. Except, of course, if you're working with huge code bases. You have to clone down large repositories and then have to do this over a slow wide area network, you have an issue. Suddenly the clone takes half an hour, 45 minutes, or longer. I'd like to have a local copy of that around. Of course, there are proxy solutions as well, but they have to be set up first. Security, we talked about that. Make sure that everything is correct. And finally, continuous integration. There's a performance issue in that if you have a naive implementation of your build servers just hammering against the same server, and they have to clone your repositories down to populate their workspaces all the time, you will suddenly find that at one stage, the server suddenly becomes a humongous big beast, or it just simply breaks down under the strain. That's an issue. Right, let's talk about a few pieces just a little bit in detail. Multiple contact. Any game developers here? No, okay. But first, of course, there's famous for, in the game development world, there are only two different kinds of software development. Video game developers, those who use Perforce and those who will use Perforce. So we deal a lot of these companies that have hybrid sources. But that might not be for games. I mean, if you're designing the display for a car, for example, these days the infotainment system is more complicated than anything else around the car. Then there's a lot of graphics in there, there's a lot of sound files in there, and so on, bits and pieces. It's binary content. If you keep this stored in different kind of silos, sound files go in here, videos go in there, images go in there, and then there's a problem because these things don't fit together, then you have an issue. How are you going to track it down? That's why in the game development world, they're all striving for having a single source of truth, one single place you can store everything. And that's true for many other companies, many other buys as well. So source code and all the other parts. Remote access. Those days where everything is in one single place are long over. We live in a global world. And obviously, you have different develop centers and different groups of people all around the world. And they want to have access to the same data. And the same, again, single same source of truth over the place. Yes, proxies can help, but they have to be intelligently built around that. Otherwise, only the people in the head office next to the server will download fast. Everyone else will take it slowly. Backup security, talked about that. Multiple repositories all depend on each other. Make sure that they have a copy of that. I know with Git, the question always comes up, I don't need a backup of that. Everyone has a backup locally available as well. But what if they're dependent on each other? And the same is true for, of course, the binary assets. And for security, if the data is in there as proprietary, if it's important, if intellectual property is secure, if your company does not want it to go out to everyone else, you want to keep a track of who has access to which data, who has access to which repository. Tools tend to have some way of that, but not necessarily. So, continuous integration. If you have multiple servers running and hammering the same machine, you have the same kind of issue around that across multiple repositories. Here's an extreme example. The Android repository comes with 1,200 different Git repositories. They're all dependent on each other. You cannot compile one of them independently. Keeping them in sync is quite a bit of work. It needs an extra tool called repo on top of that pulls them all together and makes sure that they're all consistent. You can't simply check out a branch in one of these repositories. You actually have to check them out all across the repositories with that and build it. Building that is fun. I put our main server down and almost nuked the machine by saying, okay, let's build this in parallel. Bum, off we went and took all the CPUs out. And the virtual machines died that were running in the same box. Not popular. It's a big beast. And it lives in Git. Now, originally it came up with Subversion. Subversion wasn't big enough, and then Google, in its wisdom, decided to put it in Git instead. And then they realized it didn't work and built repo and other tools around that. In reality, if you look at the big companies, they're actually building Android phones. You might find a different tool below that where the source code winds up. I'm not allowed to say which one it is. Right, solution. Well, ideally, I want to have a single source of truth for everything, from a Git repository, from binary files, and so on. And I want to have consistency across the whole set. I want to have it fast, as quickly as possible. Build is never fast enough, but having to wait for a repository to be downloaded into my workspace, my build workspace, is a pain. And I want to replicate the data. So is that where the vendor part comes in? The perforce part, I have to change my hat to come on the marketing part. So who of you does know perforce? A few of them. Okay, if you've never heard of perforce before, if the mobile phone in your pocket works, that's why. If any of the chipsets in your computer exist, that's why. If any of the games you're playing, PC or console, something like that work, that's the reason why. So we've been doing software version control for over 20 years now, and we store stuff to any size, ridiculous sizes. Pixar, familiar? They do movies. Every frame of every movie Pixar made winds up in the perforce server. They talk about petabytes like I talk about terabytes. It frightens me when I see their farms sitting behind that. Good. We store stuff at big scale. That's what we do. Fine. But perforce has been around for ages and is old stuff. What do we have to do with Git? Well, we have this tool called P4Helix, which is our single source of truth, our storage. It can take any kind of files, of any kind of size, and it can take it from anywhere, whether it's source code via Visual Studio or Eclipse or whatever tool you choose, but also via Git. And pull it out any way, shape, or form, Jenkins plugin, and all the other tools available as well. So we taught Perforce Helix this year a new trick. And that is to store Git repositories natively, internally. That means you can simply do a Git push into a Perforce Helix server, and then it will be stored there. Okay, and pull it out. Big deal. What does that give me? What's my advantage of that? Well, the benefit is that I can pull them out using Perforce proprietary methods in our workspace technology, which is different to Git, and just pulling out the data that I actually require. And that means it's faster. It's quite a lot faster. So the idea is transparent use for the Git users. They don't have to see anything, fact that there's anything different. It gets mirrored in, stored on the Perforce Helix server. And then as a build engineer, I work against that and pull the data out in the Perforce typical method of just getting the latest version of the correct files out there. When you do that, we've done some measurements, of course. Come on. That's the result we get. And this is the test with the Linux kernel, the original Git repository, the Linux kernel, which is roughly a gigabyte in size these days. It takes about 43 minutes, something like that, to clone across a wide area network. And as you can see, if I do the same thing over the same network and pull it down into a Perforce workspace, it's about 3 times faster, which means you can build 3 times faster as well. The footprint is also smaller because we don't carry all the metadata with it. There's a metadata information for that stored on the server, not on the client, which means if 1,000 build servers hammer against the same thing, then you save quite a bit of space, and obviously you save quite a bit of time. That was the whole design idea behind it. Smaller and faster. Every vendor says that all the time. I was told that's what it is. Good. How about consistency across multiple repositories? So then the same thing for the Android. The Android repositories, this case taking out 1,100 repositories across, syncing them using the standard method of Git, or also going via repo sync. But if you do this with a workspace and then do a P4 sync against that, again, smaller footprint, faster access for that as well. So under the hood, as a user, I use Git. There is nothing ever different than that. I just push it against a remote, And that winds up in a Helix server. It stores that information. And as an administrator, I can simply use a standard Perforce client, map those repositories together, and it can be more than one. I can take a subset of that as well. I can add binary data from other sources, standard Perforce sources, that as well. Bring it together in one single workspace. Build machine can go off and build this whole stuff. That's the basic idea behind it. At least that's step one. We're new to this Git world. Who knows what else we can come up with in the next 6 months, 6 to 12 months. This is a quick demo, but we're running out of time. If you want to see this working, all I have in the demo is simply showing you the workspace that loads it up. So obviously we enhanced our Jenkins plugin as well. Let me just quickly at least show that for 1 minute. So I can deal with that. Come on. You can see the console output already. So these are the Perforce commands that run against the repo to get the data out. I just want to show you quickly all the projects defined. So we enhanced the standard pipeline definition to have our own commands in there. You can either use a proprietary P4Sync or a checkount with the Perforce SEM class. And the interesting thing in this is that we use a graph source, so this is where the location is. Perforce is a single source of truth. All the repositories are in one single place, or spread over several depots. And you just address them with the correct path to find the repository you're looking for. And with that, just press build, and it pulls the data down and builds it very quickly. So, works in Jenkins as well. It's the important part for us. So, in conclusion, wake up. So, in conclusion, if you're using Git in the enterprise, it was not designed for that purpose. It brings its own challenges. And if you use Git the way that it was designed, a small little project, you don't have a problem. But many applications out there are monolithic. Many applications are much larger than you think. Many things have bunched together or consist of more than just source code. In those kind of situations, you will need some different tooling. That doesn't mean that Git is a bad tool. It's a fantastic tool to use for source code. It's just use it for the right thing. But where you store it and how you store it and how you pull the data out is a different story. As a developer, I don't care. I want it to build quickly and tell me quickly, yes, this has worked or it doesn't work. But as a DevOps engineer or as a system engineer sitting in the background, I care a lot about whether these servers have to be very large servers, whether you have to use all kinds of tricks to spread them out over different proxies and so on, or whether you can just use one single source, which because it knows it works quickly and works always stable. So, a single source of truth. Perforce, we've been doing this for a long time, so if you're interested in that, then give us a shot. And that was it. Thank you very much.